CNA security real-world labs, network security, site-to-site VPNs using VTIs. This is beyond the CNA security. I decided to include that in the series because it is a really important topic and you will find VTIs everywhere. You have focused on VPNs and crypto maps, right? Do you remember? A crypto map, you go under an interface, you apply it, you put all pieces together, and then you add new lines to your crypto maps. There are a lot of problems, maybe not a lot, but there is a couple of issues and problems with crypto maps. First of all, you cannot use dynamic routing protocols with crypto maps. A way around was to use GRE tunnels, right? Second of all, you don't really have an interface with crypto maps, and it makes your life really difficult with not only dynamic routing protocols, but with things like QoS, policy-based routing, firewalls, and so on. Almost all these issues, you can sort out all of them by using VTIs, virtual tunnel interfaces. There are two flavors of VTIs. It's a static tunnel and an on-demand DVTI. We are going to set up a site-to-site VPN using VTIs. Well, it has been done already. I'm going to show you that in GNS3, and of course I'm going to share this file with you as well. You can open it on your PC and see how it's done. And by the way, that's the easiest way you can learn new things. Take a lab that someone else did a few weeks or months ago, open it, do some show commands, show run, show IP interface brief, show crypto, and so on, and then try and recreate that lab by yourself. Let's try and see what I prepared for you. First of all, we have an ISP. Let's check that guy. Here, show IP interface brief. You'll not see a lot. It's just 3 interfaces. Not sure why I've got 3. 0, 0, 1, 1, 1, 3. Okay. Fair enough. There are 3 interfaces here. And this is your ISP. When I type show IP route, you will see that there is absolutely nothing, just directly connected networks. The reason for that is that this is your ISP, right? Your ISP has no idea about your private networks that are behind router 1 and router 4. That is 10.10.10.0 and 172.16.1.0. The site-to-site VPN will be created between router 1 and router 4. Our public IP address here is 1110 and over here is 3330. Private network 172.16 and 10.10.10.0. Let's start, and this is our host, right? There's absolutely no configuration, a default route pointing to router 4, that's it. And here we've got 2 hosts. Don't remember why I put 2, probably there was something I wanted to test at the time. Let's start on router 4. I would like to keep the topology as well if possible. Here we go. Let me scroll it up a little. Okay. Cool. Okay. Show IP interface brief. Please note we have F00 that is connected to our ISP, F01 that's LAN. In my case I named it LAN 3. I don't know why it's LAN 1 and 3, probably there was LAN 2 and I removed it. And then we have our tunnel interface. That's what makes VTI work. I'll show you the configuration inside in a moment. Let's check router 1. On router 1, show IP interface brief. You will see F00 that faces our ISP, F01 LAN 1 10.10.10.1, and again our tunnel interface 7771 and it's 7772 on the other end. And that's the first thing that you're going to notice. You are going to have a real interface. Well, a virtual interface, but you will have an interface, right? Something that you can use for things like routing protocols, firewalls, PBR, QoS, whatever you want. It is an interface, right? It is a virtual interface, of course, but it is an interface that you can use. Okay. I show you one of the hosts. Show IP interface brief. You will see one interface only, and there should be a default route. That's it. Yep. This is a host, right? We don't need anything. Show IP protocols. You will see nothing on that guy. ERGRP is running on router 4 and router 1. It's time to check our VTI side-to-side VPN now. Let's start with show run interface tunnel 3. That's what you will find inside. You have an IP address, source interface, because that is F00. It is connected to our ISP. Destination, which is 1111, that's router 1. Then we are going to use IPsec IPv4. Of course we use IPv4, right? And we are going to protect that tunnel with an IPsec profile. You can check what's inside. Let me just want to make sure that you can see that. Okay. Show crypto IPsec profile. That's right. That's the command. Inside you will see I decided to use 3des and SHA. In the running config, I'll show you that. It's here. Okay, I have an ISACAM profile as well, which is above, and inside I specified my pre-shared key, which is of course Cisco, and identity, which is 1111. Again, the easiest way to learn a new solution like that is to go through the running config and everything that is inside, then try and recreate a lab like that in GNS3 by yourself. Of course, I need a default route. ERGRP is running, that's what I mentioned. We have ERGRP. I advertise, well, it's me being lazy, right? It's 7000, that's the tunnel. interface and my LAN. Let's see if it works actually, because we have not tested it yet. We can use the same commands that you know from crypto maps. Show crypto ISACAMP.SA, right? The same things apply. We need IC phase 1, we need IC phase 2, right? We can see QM idle, that's always a good sign, and we can use show crypto IPsec.SA. And we should see tunnel 3. We can see that here. Interface tunnel 3. And here we go. We can see our ESP encrypted and decrypted. Cool. Let's check EIGRP then. Let's do show IP route. What do you expect to see? I am on router 4. You can pause the video and think, okay, what do you expect to see in the routing table with EIGRP running between these two sites? Okay, you're done. Let's check. So you should see this guy. That is our network on the other end. And again, that's me being lazy. /8, even though it's not /8. That's okay for this lab. And of course, we will we'll see some routes here from EIGRP to make sure that there are no loops in the network. Yeah, but what you expect to see is this guy here. Okay, 10.0.0.0/8. This administrative distance, it's crazy from EIGRP. Sorry, the metric is crazy. It's okay, and we go to 7771, which is tunnel 3 on the other end. Yeah, we can ping it. 7771, right? We can ping it. And we should be able to ping our host, which is 10.10.10.3. Here we go. Took a while. Okay, we can ping it. Yeah, that's VTIs in action. It's not difficult. As you can see, 10, maybe 15 lines to make it work. Let's check router 1. We should see the same here, really. Show crypto ISACAMP.SA, QM idle, 1111, 3331, that's okay. Show crypto IPsec.SA. It identifies tunnel 3, interface tunnel 3. I am using 3DES and SHA-1 at the moment. That's okay. It's okay. I can see encrypted and decrypted. Of course, it has to be like that because I was able to ping across this tunnel. It is pretty important to check that. You want to make sure that IPsec is working, right? You want to see encrypted and decrypted packets. Show crypto IPsec profile, the same thing. Again, the same rules apply. You should try and mirror both configurations, right? That's what I wanted to cover in that lecture. I hope it makes sense. I showed you a really basic site-to-site VPN using VTIs. I encourage you to download the files that I prepared for you, or go online and use a template. It's everywhere on Cisco and on all other websites. Play with VTIs, make sure that you understand how it works. Why? Well, because you will find that in the real world. Thank you very much.